Okay, so today we're doing some right triangle trig. Now, some trig functions that you probably saw in the first test and you probably had no idea what it was talking about. We have some trig functions, we know that's right here. Okay? Sine is S-I-N-E. The abbreviation for sine is S-I-N, theta. Theta, remember, is the degree or the measurement of the angle. Cosine, abbreviation is COS, and theta. Tangent, abbreviation is tan, theta. Okay? Now, these have a relationship to the triangle. If you're trying to find a missing length of a side, and you only know one length of a side, you can't use Pythagorean theorem. You can use Pythagorean theorem when you know two lengths, and you can find the third length. Or if you're trying to find the angle, and you know two lengths, then you can use these trig functions. So these help you find a missing length of a side, if you only know one length, or it helps you find measurement of an angle of a triangle. Okay, so this is an extension past Pythagorean theorem. Pythagorean theorem only works for the side lengths. Sine is the ratio opposite over hypotenuse. So we just practice labeling opposite and hypotenuses because it's important to know which is which. Cosine is the ratio of adjacent over hypotenuse. Tangent is the ratio of opposite over adjacent. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, and we have a nice little phrase that helps us remember these. How do we remember these? Sine, capital S, is opposite over hypotenuse. So, cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. I'm going to say that. SOHCAHTOA. One more time. SOHCAHTOA. SOHCAHTOA would be your friend. It's a really easy way to remember these ratios. So, sine is so, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tells you the order, because the order of ratios is important. Tangent is opposite over adjacent. The reciprocal is the flip, right, of sine. And the flipping sine is reciprocal function, which would be hypotenuse over opposite. Okay, this one is cosecant. Cosecant. The abbreviation for cosecant is CSC, theta. We won't actually be using cosecant, these reciprocal functions this year. We're going to use them a lot more next year, but just so you're aware of what they are. Okay. So the reciprocal function of cosine is secant. Secant's abbreviation is SEC theta. So, if cosine is adjacent over hypotenuse, what's the reciprocal? Hypotenuse over adjacent. And the last one, tangent's reciprocal function is called cotangent. So each of these have a three-letter abbreviation. So this one is COT, C-O-T, theta. If tangent is opposite over adjacent, what's cotangent's reciprocal function going to be? adjacent over opposite. So it's the reciprocal ratio. Okay? Now, these reciprocal functions, this year we're not really using, but next year we're going to be using them a lot. So that's just an introduction. We'll be focusing this in the black sine, cosine, and tangent. Okay? So, number example 1, find the values of the 6 trig functions. This is of theta. This is what you need to do when we're doing a triangle correctly. So you can see theta right there. And the right angle, would you go through and label these adjacent, opposite, and hypotenuse? Before you start writing the ratios, you should label the triangle. We just practice this, so hopefully you get it right. Okay, Aaron, what did you label the 1? Thumbs up or thumbs down, do you agree? Yeah, and this is our theta, it's pretty easy. Theta, okay, Aaron, what did you label the 5? Thumbs up, thumbs down, yes or no? I agree. And so this would have to be the hypotenuse, is that right? So it's across from the 90-degree angle. You make sure yours matches, that's correct. Thanks, Aaron. Okay, now in this case, we know 2 sides of the right triangle, but we're missing the third. How do we find the third side? If you know 2 sides of the right triangle, how do you find the third side? The diagram theorem. So this goes to 9th grade, the diagram theorem with you. Actually, we're going to do it on that last problem from your homework. I used the diagram theorem a little bit. Remember what the diagram theorem is? Yeah, a squared plus b squared equals c squared. And one of these has to be the hypotenuse. Which one's the hypotenuse? It's c. Okay, so in this case, it's the hypotenuse we don't know. So c squared, we don't know c squared. But a and b, it doesn't matter which one's number 1 and which one's number 5. You just plug them in. 1 squared plus 5 squared. I get 1 plus 25 equals c squared. So 26 is c squared. So c is the square root of 26. Now you want to make sure this is in simplified form. How do you know if this radical is simplified? We're going to begin in the year to practice simplifying radicals. Factor tree. Does that sound familiar? Okay, Christine, what 2 numbers multiply to 26? It's even, right? So 2 times something. Or what's half of 26? 13. Good. Okay, which one of these breaks down? None of them. Do they match? No. So this is as far as we could go. So our hypotenuse is root 26. Okay, so now we have all 3 side lengths. So we can write the 6 trig ratios. Okay, sine of theta. If we know the measurement of this angle, say this angle is 48 degrees, we put sine 48 degrees. We don't know the measurement of the angle, so theta is the placeholder for the measurement of the angle. Sine theta, remember, is opposite over hypotenuse. So, okay, so we need the opposite number over the hypotenuse number. Okay, Zainab, what's the opposite number? Find the hypotenuse number. Good. Now, there are some things we don't ever leave in the denominators and fractions. We never leave i's in the denominators. We never leave square roots. Or something else. Fraction, we never leave fractions in the denominators of a fraction. Do you know how to rationalize the denominator so that we don't have a square root? The denominator, where we push it up to the top. What? I can multiply by a fancy form of 1. So we're going to multiply by that square root to get rid of it. I'm going to choose to multiply top and bottom by root 26. Because root 26 divided by root 26 is 1, right? I'm not changing the fraction by timesing by 1. I'm just manipulating it into a different form. So my numerator is 5 root 26. And my denominator, root 26 times root 26, square root 26 times itself, the square root just goes away and we have 26. Okay? That's the sign ratio. And you don't have it in your calculator, you get a decimal. Okay, just leave it like that. Cosine theta. So, adjacent over hypotenuse. Okay, that's the cosine ratio. So what are the numbers? Yeah. 1 over 26. Here again, we have that same problem. That was square root in the denominator, so we have to rationalize the denominator. How do we do that? We just did it in the last problem. Yeah. Fancy problem 1. Okay, so the numerator is just 1 times root 26, which is just root 26, over, what's root 26 times root 26? Just 26. And so now that our radical that can't be simplified is pushed up to the top. This doesn't always happen. Because when we're on tangent, we're not going to have to do it. Tangent theta, SOHCAHTOA, TOA, opposite over adjacent. Okay? TOA. Remember, it's the opposite over adjacent ratio. Good. 5 over 1. Do we have a problem with the denominator here? No. So we can just say it's 5. So that one's nice. Okay? Because we passed for all 6, we're going to keep going. The next one is cosecant. Now, the rate is the same to remember cosecant. It's called, I can't ever say it very good. Shut. Look. One. You didn't go in the same order though. You started with this one. What is it? Cha-cho-cow. That's what it is. Cha-cho-cow. Cha, so cosecant, cho, cow. I don't remember that very well. I just do a SOHCAHTOA and flip it. That's easier for me. Okay, so what I'm going to do for secant is the reciprocal sine. Go back to the original sine function. I don't want to use this one, because if I do that, then I have to rationalize my denominator again. But if I use this one, then it will work out nicely. So I go back to the original sine and flip it. So cosecant, maybe I should actually put the theta in. Cosecant theta, I do the reciprocal 5 over root 26, I just get root 26 over 5, and I don't have to rationalize it because the denominator is just an integer. Cosecant theta. Go back to the original, not that I didn't rationalize. Okay, Sean, what would the reciprocal of 1 over root 26 be? So, yeah, root 26 over 1, which is just root 26. And tangent. Not tangent, cotangent. Okay, it was 5 over 1, so we do a reciprocal, it was just 1/5. Okay, any questions about finding the 6 trig ratios? Okay, now we're going to use this information, these ratios actually solve. Now, notice, oh, I didn't get one of the letters on there. Okay, notice the vertices of our shapes are capital letters. This, I think, is supposed to be a T. So, remember that capital T. Opposite of that angle is a lowercase version of the letter. So 68 degrees is angle K. So the opposite side is that 5. angle code, this 5 is little k. Okay, so there's a relationship of how you label. So if this is big T, the hypotenuse would be little t, because it's clear across, okay? Then the air is on the top, so the base, which is opposite, would be little a. So we're going to find the missing sides and angles. We can't lose the diagram here because we only know one side length. This time we know it's a right triangle, so we have trig functions we can use. And we know this degree is 68. We know what measurement of number A is. What? How do I know it's 22? Yeah. Triangle angle sum. You take 180. We know we have 90 degree angle. So we need to just subtract the 68 from 90. And you get the missing angle of 22 degrees. So fill that in. The measure of angle A is 22 degrees. Okay? Now let's find A, little a. We're going to use 68 degrees as our theta. Does everyone have a calculator, by the way? Everyone needs a graphing calculator. Help them get one if you don't have one. Okay, the 68 degrees is our theta. We need to label opposite, adjacent, and hypotenuse. Okay, the 68 degrees is theta. What would T be? Opposite, adjacent, or hypotenuse? Hypotenuse is opposite of the 90 degree angle. Hypotenuse. Okay. And K, 68 degrees is our theta, or little kb. Opposite. It's clear across. Okay? And little a would have to be the adjacent. Okay, so let's look at the information we know. Say we want to find T first. T is the hypotenuse, and the only other side we know is the opposite. Think about it. SOHCAHTOA, which has an opposite and a hypotenuse in SOHCAHTOA. Opposite and hypotenuse. SOHCAHTOA, sine, cosine, or tangent, which has an O and an H. Sine, so that's the ratio we're going to use. Okay, sine theta is opposite over hypotenuse. Okay? So, we're going to replace theta this time though, because we know what theta is. Theta is 68 degrees, so when we sine 68 degrees, you put a degree symbol with it, equals 40. You take it off, please. Opposite, we know the opposite is 5, and the hypotenuse is t. Okay, our goal is to solve for t. How can we solve for t? What? Now, 68 is not being multiplied as sine, it's the sine of 68 degrees, so it's within the function. If I put that over this over 1, so they're both fractions, then I just do a cross product. Okay, so take the denominator and that numerator. T needs to go in front now, okay? Make sure T is in front times sine 68 degrees equals 5 times 1, which is just 5. Now to get T by itself, it's T times sine 68. So the inverse of timesing would be dividing. Divide by sine 68 degrees. The sine and the 68 degrees are glued together. This is not sine times 68, it's sine of 68. Make sure you divide on both sides. So, now we need to check to make sure everyone's calculators are set up correctly. So, I'm going to show a graphing calculator, hopefully. Get my camera on here. This one. Okay, the calculus kids are going to hate you because the calculators have to be in radian mode, and you're going to change them all to degree mode. Okay, so see this mode button right here? Okay, that. We knew that on the grid line there are two different degrees. There's a radian, which we'll be using a lot more in secondary 3, and what we use this year is degree mode, because we're doing 68 degrees. We need to make sure the degree is highlighted. So come down here and highlight degree. Okay? And with that set up, then you can type in your problem. I forgot what it was. Was it 5 divided by, you see the sign button? Above the 7, there's a comma, and then there's sign. Or is it 5 divided by sign 68? Is that what we need? Okay. 5 divided by sign 68. You don't need to put a degree sign. Okay? Sometimes they come out nicely, but most of the times they're pretty awful decimals. Okay, so we're going to take this out to 3 decimal places. 5 point, unless directions tell you otherwise, take it out to 3 decimal places, okay? 5.39, what would I say next? 3. 5.393. So T is 5.393. Okay, and this is a length, it's not a degree. So down T, we can't use Pythagorean theorem right now to find A, because this is rounded. Okay, so we have to use 3 identities. Oh man, I'm going to survive the day. We use 3 identities to find A as well. So I'm going to erase this green circle. Maybe. There we go. Still, the only true value we know is 5. Now we're going to go find little a, opposite, and adjacent. So Katoa, which one has opposite and adjacent? Tangent, Toa. Toa. Okay, so we're going to now use tangent theta, which is opposite of the hypotenuse. Still using 68 as your theta. Tangent 68 degrees. Oh, yeah. Thank you. So, okay. So our opposite is 5. And adjacent was unknown. When the unknown is denominator, how can we solve for it? What do we do in the last one? Not just multiply, but we cross multiply. So put that over 1, cross multiply. That A needs to go in front. Okay, don't put it after the 68 because that's confusing. A times tangent 68 degrees equals 5 times 1, which is just 5. Okay, can we see that? How do we solve for A now? Good. Your calculator has to be in degree mode in order to do this. If you're in radian mode, then you get the wrong answer. So whenever it comes to calculator, we practice that. Since I haven't really calculated, I'm going to have to make sure I know if you're home, use your own calculator that you say. You go back to that mode button, make sure you choose it to degree. Good. You see the tangent button is right above the 9, 2 buttons above the 9. Let's see what's out of 3 decimal places. Raise your hand when you have it. 5 divided by tangent 68. Out to 3 decimal places. And there it was again. Zero. Yep. The back of the 0 is a 1. Okay, so those are the approximate lengths when we did round of A and T. Okay, flip it over. Yeah. I will remind you what. Oh, you did inverse tangent. So that -1, that's an inverse. So we just want to use the regular tangent. Okay. So Some special triangle relationships that I'm supposed to tell you, but in my opinion, they're not useful because I can't ever remember them. I can remember SOHCAHTOA though. So, 45, this is a 45, 45, 90 triangle. Remember that theorem about basing as being congruent? What type of triangle has basing as congruent? No, spring break was too long. What type of triangle has basing as congruent? You study this, we just had a test on it. Isosceles. So the outside and outside are congruent, which is why we both mark A and A. So when there's a relationship that happens, the hypotenuse of the isosceles is always the side length times square root of 2. Okay, this one, 30, 60, 90 triangle. There's always this relationship that happens, but I can't ever remember it, to be honest, so I just use SOHCAHTOA. It's easier for me. Okay, opposite 30 degrees is your length A. Your hypotenuse is twice that length, and your 60-degree opposite of it is A root 3. Anyway. I think we're going to skip this part, because really then it's more next year that you need to work with that. So let's just keep practicing with our right triangles. I didn't copy very well. Okay? 45, 45 means this triangle is an isosceles triangle, which means this side is congruent to the other side. Left side, which means this has to be 9. So to find H, if you look at our special relationship, both sides are 9. The hypotenuse has to be 9 times what? Look at it there. The A is 9. 9 times square root of 2. So if you can memorize these special triangles, then it's easy, but when I work it out, I usually have to revert that to SOHCAHTOA because I can't memorize those. Okay, here's another one. Okay, A in this case is 2 roots 2. X is supposed to be A times the square root of 2. That A was 2 root 2 times root 2. A was 2 root 2 times root 2. What happens when you do square root of 2 times square root of 2? Square root of 2 times square root of 2 is square root of 4, which is just 2. So this is 2 times 2, which is just 4. Alright. This is the... I don't want to do these ones anymore. Let's go down to number 7. I feel like these are more important because no one's going to ever memorize those special rectangles. Okay, find the measure of each side indicated. Ooh, that one 11. Is that what that is on your paper? An X and a 37. Okay. I'm going to find X. Notice where your theta is. 37 is your theta. You have to label your triangles correctly or this will never work. So go ahead and label your hypotenuse, opposite, and adjacent sides. If they get labeled correctly, then all your work is going to be wrong. So make sure you learn to label correctly. Okay, Nancy, what did you label on the 11th side? Yeah, this is, our theta is right here, 37. Yeah, so it's creating that angle that has to be adjacent. That's the X, Nancy. Good. Which means the base clear across the triangle has to be opposite. So you need to look at the 2 pieces of information you know. You know the hypotenuse is what you're looking for, and you know the adjacent is 11. So hypotenuse and adjacent, an A and an H. SOHCAHTOA. Which one has an A and an H? SOHCAHTOA. Cosine, yeah. Cosine theta is A over H, ka. So our theta, we have amount of degrees. So we're going to replace theta with 37 degrees. Adjacent is 11, and we're looking for that hypotenuse, h, which one we can put as x. Okay? So same steps as before, we cross multiply, and we divide and plug it into our calculator. Over 1, cross multiply again, make sure that x is in front, times cosine 37 equals 11. And then you just divide that cosine 37 degrees away and plug it into your calculator. Okay, type into your calculator. 11 over cosine 37, close the parentheses. Okay, Tyler, tell me what you got. Good. And why did I put this in those squiggly lines? Because I'm rounding it, right? Oh, these directions though actually do tell something different. This one says every is 10th. So that would be 13.8. So if the directions say differently, round to what they asked for. Otherwise, always round to two decimal places. Let's look at that. This one actually has something different. This time you're finding you're missing an angle. And this is the button Chris accidentally used just a minute ago. Okay? So I'm not going to copy very well. Is that a 6 or an 8? That's a 6. Okay, and this one's a 9. And I put it right there and right angle. Okay, first you always have to label. So label your adjacent hypotenuse and opposite sides. Okay, so you said, what did you label the 6? Good. What did you label the 9? Mm-hmm. And that one will be opposite. Okay, that's correct. So make sure you match it. Okay, so look at the two pieces we know. We know 6 is adjacent, and we know 9 is hypotenuse. A and H, so Kanatoa. This one has the A and the H. Which is cosine again. So cosine theta is adjacent. Adjacent to the hypotenuse. Okay, so let's replace everything we know. Do we know theta this time? No, so we're going to keep theta in here. So this one's different. Adjacent is 6, and hypotenuse is 9. And if you want to simplify that, you can simplify it. Okay, so whenever we're solving for something, we're always doing inverse operations. Do you want to do division, we would multiply, right? Do you want to do addition, we would subtract. Okay, the inverse of a cosine, we need to break, this is not cosine times theta. We don't divide. The inverse of cosine is inverse cosine. Ooh, not bad. The inverse of cosine is inverse cosine. Look at your calculators. In blue, most of yours is in blue, this one's in yellow. But right above sine, cosine, and tangent, you can see sine -1, cosine -1, tangent -1. -1 means inverse. So what we're going to do is I'm going to group the whole thing, and do cosine to the -1, which is actually called the inverse cosine. That cancels out the cosines and drops the theta by itself. We're going to do it on both sides. So we're going to group this whole thing and do cosine -1. So it becomes cosine -1 of 6 minus, or if you feel like writing 2/3, you can write 2/3. And then it's just put it into your calculator. This time you have to use the cosine -1 button. Okay, so let's, I think I have my calculator. There we go. So you don't just use regular cosine, you use inverse cosine. So make sure that you have second cosine. You don't have that -1. So it's divided by 9. Okay? So I don't know, does the direction size have around this time? Does it say tenths again? Okay, so this would be 38.2. Okay, oops, too far. 48.2. And that's the measurement of the angle. So what should I put after the 2? A degree. So when you're finding theta, you're actually in a degree. Okay, let's just pick one more of these two. Which one looks like it's, I don't know what you want to do. Grammar, because there's decimals. Okay, so we have 7.7 right here. And it looks like a 14. And it was just theta. Based off of the position of the theta, we're going to do adjacent, opposite, and hypotenuse. Okay. 80. What do you label 7.7 as? Huh? 14? Okay, so this would be hypotenuse. Okay. So the two pieces of information we know are adjacent and opposite. Adjacent and opposite. So Katoa. Which one is that? Tangent. Toa. This is a good one. We haven't done tangent yet. Tangent theta is Toa. So opposite over adjacent. So this time again we don't know theta, so we keep theta in there. Opposite is 7.7. I'm going to leave a little space, but then I'm going to have to put an inverse tangent right there. Over 13. Okay, this is not tangent times theta. This is tangent of theta. So what's the inverse of tangent to break theta free? Well, inverse tangent, yeah. The tangent for -1, but you have to group the whole thing. So group the whole thing outside your tangent -1. This is not timesing, this is of tangent theta. And those cancel each other out and we get theta by itself. Let's do on both sides though. Tangent -1, group that whole thing. So the inverse tangent of 7.7 over 14, and then that's the 10th, that's the direction set. Make sure you use the inverse tangent when you're heading to your calculator. Okay, put your arm together. Ooh, good. You use a degree. I'll do squiggles because they're rounded. 20.8.8 degrees. Okay. And then the elevation and depression, a pretty simple one to talk about next time. The elevation comes from your eye level. And if you elevate, does that mean go up or down? Look up, so it creates an angle. And depression means look down, which creates an angle. So maybe we'll talk about that next time. So your homework has a screen packet, lots of extra credit. The circled ones, on the first page and the last page, it's the circled ones required, the others are extra credit. But these two sides, it says all required. Okay, that's practicing your Stochastillas. So after you get your packet, if you have any calculators, go and put it back in the box, please. And people who I ran off, please do stage portal. You can use the school library if you need to, or you can even do it at home. Make sure you give me your work, write down your work, and then your problems.